My name is Adam,
My name's Eric.
and this is our Python programming project. So we are working on a visualization of a large data set on a web map, and this is what you see here in front of you. So we will walk you through some of the stuff we did to get this together and some of the code as well.
We required four major libraries outside of the standard Python libraries. One of those is SolarPy 3. It's an API interface for the Solar database, which we get our information from for our ship mapping. Another one is NumPy, which is used mainly for data structures and storing different information in NumPy arrays and such. And then we use SciPy. SciPy is used to create our KD tree, which stores all of our ship information. And then the last one is Flask. Flask is the web application or web server application that we use basically to run our server. So we use Solar as the database that we query to get all of our information from. It basically contains a large set of oceanic data about ships throughout the world. We use the ship's location information to plot where they are on the map. At the beginning, we query Solar a certain number of times, which is a limit that's set in main, and we get information about that number of ships back and put them into arrays so that we can later store them in the KD tree.
Alright, so the KD tree, I'm going to talk a little bit about this. So after Solar returns the data that we requested from it, we have it stored in memory inside these arrays. So after that happens in the constructor, we pass it along the location data array to this CKD tree, which is a C written library which provides parallel processing, a lot of performance optimizations in the background for performance. And we use this KD tree for a k-nearest neighbor search algorithm, which we use two different ways actually. One where k equals 1 to get a closest point, and in other cases when we are populating the map with multiple points, we query the KD tree with multiple inputs. So I'll let Eric go ahead and talk to you about how that works. Or I suppose how clustering works.
Yeah, so once we get all of our information back from the server to the client side of the application, we have a JavaScript in there that does clustering for us. And so we found that when we first did this project without clustering, we had tons and tons of data points trying to be rendered on the map in a very small location. And so all these very dense points caused the application to be very slow, since it had to visualize so many markers for each query and for each data set that we brought back to the map. And so the way we fixed this was by doing clustering. And clustering is done by breaking the space that you see into a grid, and then for each tile you choose a random center point in the tile, and that will be the cluster center. And then for a bounding area around the cluster center, points will be gathered and stuck together. And then once all this is done for each tile, all the ships will be into their separate clusters. If a point for a ship is within two different bounds for cluster centers, then the shortest distance is taken to figure out which cluster it should be put into. Also, if you mouse over the clusters that we have on the map, it shows you their area for which they have ship information.
Alright, so another feature that we added to this map is a way of getting extra information other than just position So these all represent individual records that are taken by these ships traveling in the ocean. And if you click anywhere on the map, we will take the coordinates that your click is at and use it to find the nearest point with the k nearest neighbors algorithm, and that is for k equals 1. So whichever point our server tells us that you clicked to, we will use the associated metastring that was gathered from Solr to query Solr again and give us extra information regarding that point. And that includes things like salinity, temperature, winds, speeds and directions. And we also have provenance link that you can follow to the original source of the data, which you can use for spot checking or if you would like to get extra information.
Yeah, so for all of these queries to the client, or from the client to server and server back to the client, we have to use the bounding box of where the user is actually looking. And so this is the outside latitudes and longitudes that are the current screen that the user can see. And so we send this information back to the server, and what the server uses this for is the location in which to look inside the KD tree. And basically we do this by breaking this bounding box into 12 linear space locations. And for each location we will search a radius around that spot in order to get the ship's information that we need for that area. And the radius that we chose is the radius that covers the entire area based on, for 4 points, each radius will touch at a singular point in the center between them. So once we have all this information, we query the tree for k nearest neighbors to get the number of points we can back for the map, and those will be sent back to be visualized.
Alright, so a lot of this front-end software is done in JavaScript, and it uses plugins for the Leaflet library. Leaflet is a JavaScript library built on top of OpenStreetMaps. OSM is it's a service online that you can query to get base map tile layers that are loaded in the background. So in reality, all of these ship points are actually being placed over a grid which is just colored with these tiles from OpenStreetMaps. And Leaflet, the library, allows us to add various plugins and extensions to do different things, such as this clustering, placing the latitude and longitude from the mouse, as well as this mini map off to the side. It's a very powerful tool that makes it very easy to handle large data sets on the web. So I think that's all we have for you today.
Yep, that's it.
I hope you enjoyed it. You can check out our GitHub. We'll have more stuff on there. And that's all.